Okay, so hello everyone, this is Akshay here and welcome back to the another great day of our period streak. But before proceeding ahead, so we will solve the yesterday's question first of all. And I can see multiple comments that भैया ये solution चल गया भाई, तो वो solution आपका चला इसलिए है क्योंकि यहाँ पे जो sorted term है इन्होंने अभी ऐड किया, राइट? तो पता नहीं आपने solution कैसे लिख लिया, हमें भी आपने गेस कर लिया होगा कि ऑलरेडी sorted है, तो आपने लिख लिया होगा, राइट? बट अच्छी बात है, ठीक है. एंड इससे अच्छी बात है कि पीओडी स्ट्रीक नहीं ब्रेक होगी. बट फॉर मी, let me just get back to the email. So for the email where we have raised the bug, so they have like uh, sent me a satisfactory answer that thank you for bringing this to our attention. We have read the problem to avoid the ambiguity in the future. Great. So there was actually a missing term here, sorted, and that was where all the things were happening wrong, were going wrong. Okay, so I hope you have read this question that we have given two array and we have x value, so we need to form a pair which has the sum closest to this given x, right? So to solve this question we have two approaches. So first of all, that we will form all the possible pairs and see which pair has the sum closest difference to x. We will do that. So forming all the pairs will give you a time complexity of O of n square and space complexity O of 1. So this would be your method 1. So we will be using a two nested for loop, right? For one for loop for iterating in first array and another for loop for iterating in the second array, and that's it. You will just maintain the sum and you will compare it with the difference of sum minus the given x. Whenever in the next iteration it keeps on decreasing, that difference keeps on decreasing, we will update our answer. So please pause this video, try to code this approach, brute force first, and then we'll move on to the optimized one. Okay, now we can see the expected output and output matches, and since we are learning here, so we will always start with the brute force and not directly jump to the solution. This gives us the thinking that how we should think in terms of a given solution, right? Given problem. So before hitting the submit button, a question goes to again, will this solution be submitted? As we can see, the n and m is going to 10 power 5 and we are using a time complexity O of n square. So definitely we are using an iterations which is equals to 10 power 5 ka square, which is 10 power 10, and this is definitely greater than 10 power 8, right? So that is why this solution will give us TLE, correct? Let us now hit the submit button and verify the time limit exceeded coming, and then we can move on with the second one. Okay, great. So for 1111 cases it passed, and for rest of the cases definitely 89 cases we are getting the TLE because the iterations must have going over bound of 10 power 8. Now the method 2 is regarding the second pointer, and here the one condition to make this second two pointer work, the array must be given as sorted, right? So that's what I was saying in my previous video, that if the sorted is not given and we are explicitly sorting the given array, just as to make this two pointer work, then definitely we'll be using an extra head of time complexity of n log n. But now they are given, since it is already sorted, so that n log n would be not evaluated in a time complexity. So let's just take the first example and do the procedure. Okay, so now listen closely and let us move ahead with the second approach. So here we will have two pointers. The one pointer will start from here, this ith pointer, and this would be our jth pointer, right? So let me use some different colors. Okay, so what we'll do, first of all, we'll form the sum of the pair, right? So the pair is pointing, the first integer is at this element and the second pointer is at this element. So this is the second element. So if I just sum it, so it would be 41, right? And I need to calculate the difference with the given x. X here given is, what is the x given for this 32, right? So we will calculate the difference with x. X is nothing but equal to 32. So I will do 32. Now why I'm taking modulo here? To calculate the closest integer, why I'm taking modulo. So let's just see these two examples first. So let's say you are given x is 30 and the pair of elements is 15 and 19. If you sum it, it would be 34, right? So if you do 30 minus 34, which will give you minus 4. But we know the difference is just 4 spaces or 4 integers ahead. So that is why to make this minus into a plus 1, we are using a modulo, correct? Now we will check. So first of all, we'll have our difference. The initial difference, let's say, is pointing to plus infinity, right? We will check the difference is what? 41 minus 32 is 9, right? So this 9, at the first iteration, it must be less than infinity, and that is why we have appointed initialize this difference as plus infinity and not as any other variable, right? So we wanted for the first iteration, we wanted to happen this inequality and store that particular pair in our answer, correct? Okay. तो difference, यहाँ पे difference लिख लेते हैं, and then we have the elements that is to be part of the answer. So 9 is definitely less than infinity, so our difference will be updated as 9 and our answer would be 40 and 1, right? Or it's a 1 and 40, whatever be it, right? Now in the second iteration, what will happen? Now my current sum, my sum is 41, right? And it is greater than my given x. That means if I reduce my sum anyhow, then I will get a difference which is lesser than my current difference. Definitely. Now, my motive is to now reduce the sum of the pair. How I can do this? Can I move I to its right hand side? Definitely not. Because if you move it, it is present in ascending order. You will get, after 1 you will get 4, and then 40 plus 4 will give you 44, right? Which is greater than your previous sum, that is 41. So definitely we cannot move I in the right hand side direction. Can we move J in the left half? Yes, we can move left, because it is now, since it is in ascending order and we are moving from right to left, then definitely from 40, if we move left hand side, we will get a lesser element. So we will do, so there goes our one condition. So if array of I plus array of j is what? Greater than x, then I will do j minus minus. So I'll move it and my j will be here now, right? I will again calculate the sum, it is 31, and I will do 31 minus 32, which will give you 1. 1 is again lesser than our previous difference, which is lesser than 9. So our difference will be updated as 1, as well as our answer element would be updated as 1 and 30. Correct? Now again, now what is the scene here? That my current sum is less than my given x. Definitely I need to increase my sum. Can I move j towards right hand side? You can move. If you see that the j in the right hand side will have elements 40, and 40 plus will give you 41, which is greater than your given x. But can you see that we will be doing a redundant operation? If we move in the right hand side, then definitely all those cases have already been handled, because we are already coming from right hand side to left hand side in the second array. So that is why we will not make a call to move to the right hand side of the j. Instead, now can we move in the left hand side of the j? So if you do it, then you will get a even lesser value with your current sum. And I want, my sum is already lesser than my x. I want that sum to go as close as to the given x, right? So that's what I'll make a move. I'll make a move towards the ith pointer. I'll move it toward its right, right? So I will be now shifted to here. And as you can see, the current sum would be 30 plus 4, which is 34 modulo minus 32, which will give you as 2, right? So my current difference is again greater than my previous difference, so I will not update my difference, as well as my answer will not update it. So I'll again move my I, correct? Okay, so this time I'll not move my I, right? So let me just yeah, I'll not move my, because my current sum is 34, which is greater than my given x. So I will move my j. So j will come here. Again, my current sum would be 24 minus 32. What is the difference? It would be 6 and plus 2, 8. Now 8 is again greater than my previous difference, that is 1, so I will not update it again. Now I can see that my current element or the current sum is 24. I'll increase my sum in hope that I'll get closer to the given x, so I will move my I ahead. Now it would be 25 minus 32. What is the difference? It's 7. Again, it is greater than my previous difference, so I will not move it. Again, the sum is again lesser than my given x, so I will move my I pointer one more ahead, and I can see it is 27 minus 32. And what is my current difference now? Difference is 5, which is again greater than my previous differences, right? So I will not update my difference and element. Now again, my sum is lesser than x, and so I'll move my I pointer ahead in hope that I'll get closer to x. But if I move it ahead, you can see that we are going out of bound. So here we will stop. Here we will stop. So definitely we don't know how many iterations we are doing, because we are moving one time in right hand side in I, left hand side in j. So that is why we will use a while loop. We will have a pointers I and j starting in the starting and the ending index of the second array respectively. And there would be one more if, that if array of I plus array of j is less than x, then what we need to do, right? If it is less than x, then we need to move our I pointer, right? So I will say I plus plus, and that's it. Now it is up to you to complete the whole pseudo code. I have given you enough intuition, enough dry run is required. Whatever the required dry run was there, I have given it to you. Please pause this video now, try to code this approach, and then you can resume ahead. Okay, so here goes our method two. We have initialized a difference and a and b variable just to store. Whenever we get the answer, we'll store that particular answer in this a and b, and then at last we'll return it in the array list. We have a first pointer L starting the first element of the first array and the last element of the last element of the second array into the rth variable. Let's say r variable. Now we were checking if the particular sum, pair sum minus x of the ABS values is different of our given difference. Then first of all we need to push that element into our possible answer, and then we will update the difference as well. And in rest of the cases we will check after this is done. After this check is done, we will check if the pair sum is greater than x, then definitely we'll move the second pointer, that is the last, which was pointing to last element of our second array, towards the left hand side. And in else cases, if it is the sum is lesser than x, then definitely we need to increase our sum and move our the first pointer, which was initialized to the first array, into the right hand side, right? That is moved to the greater side. Yep, move to the greater sides. And at last, whatever be the possible answer would be there, it would be stored in these two variables a and b, and we'll add it in the array list and we'll return it. Now let us hit the submit button. And what is the time complexity? Meanwhile, we can analyze it. So we are moving. So in the worst case, we'll be covering all the elements present in the two array, right? So it would be not actually O of n. It would be, to be precise, it would be O of n plus m, right? But let's say the both the array elements are same, it would be like O of 2n, right? And ignoring the constant, you can say O of n. But then again, let's be precise. Let's say O of n plus m, but it's still a linear time complexity, and that is why. And that is why it is getting submitted, because n and m is both pointing to 10 power 5. So in the worst, I'll be using 2 into 10 power 5 iterations, which is less than 10 power 8, and that is why our solution will get submitted. Okay, it's really showing. So I just refreshed the page and submitted it again. You submit ho gaya, right? I don't know what's happening in the backend of GFG. Maybe as you're saying it's correct, the problem setter guys or notice field, I don't know what's happening. So yeah, so we have scored the point for this question. Now let us move ahead with the today's question. Today's question is about the wave array. It's a very easy question and it would be over in just 1 minute. So let me just hide the solution first. Okay, I can see that you have already saw the solution, but yes, let's again visit the question again. So given a sorted array of distinct integers, and if there are multiple solutions, so we need to form an array wave. Array wave is nothing but the first element should be greater than the second. Subsequently, the second should be lesser than third, and the third should be greater than four, and this pattern should be followed in the entire array. Right, so this is the 1 2 3 4 5, and you need to return 2 1 4 5 3, right? Similarly for the next 2 4 7 8 9 10, into 4 2 7 4 2 8 7 9 10 and 9, right? Please pause this video here now. The hint is please try to find some pattern in the given array and in the output array. Is there any pattern that we can just code that pattern and you can get the answer, right? Please give yourself 2 to 3 minutes and you'll be able to get it. If not, let's resume back. So I hope you were able to find it now. And yes, so the pattern here is that you just need to reverse. We just need to reverse, or let's just swap the first two integers and then the another set of first two integers, and then subsequently you need to swap the group of two integers in the entire array, right? So if you'll be swapping 2 and 1, the first two you'll be getting 2 1. Then the another two is 3 4, you'll be swapping, it will be getting 4 3. Then the last one is not forming a pair, so we will leave it as it is. Similarly here 2 4 is swapped, then 7 8 is swapped, then 9 10 is swapped, right? So we just have to write a code that to swap the integers present in the group of 2, and that's it, will be done, right? So that's the code here. For n t equals to 0, we are going till second last element in hope that it may form a pair, right? And we'll be moving, instead of moving I plus plus, we'll be doing I equals to I plus 2, and then that's it. In Java, we do not have a direct swap function, so we'll be using a third party variable, that is t here, and the swapping would be done. Great. So what is the time complexity that we are? Okay, so my streak has went down to again 1 day. Maybe I'll use the coins to use the time machine to get my streak back. Because it happened twice in my streak that they have said the wrong question and I'm the one who is suffering. So okay, leave it be. So this question is in the time complexity of O of n because we are using a for loop till n times, right? Let's switch back to the C++ code and let's just hit the submit button for this code as well. And meanwhile it is submitting, so I didn't show you the C++ code for the swap, this closest pair, right? So that's the C++ code here. And do not worry, you will get all the source code in my DSO repository. I'll mention the link in the description. So that's the method 2, and that is the method 1 of the brute force. And yeah,